Okay, all right, guys, we're going to start discussing the second part of the Ohm's law formula. I introduced the first one in the past video, and that's the one where you can find, if you've got two of these variables, you've got the energy, the current, or the resistance, you can find the third one. There is a fourth property of electricity that we haven't really discussed yet. And it's one that it's completely related to the three we use in Ohm's law. And in fact, we have a secondary triangular formula that is sort of an ancillary part of Ohm's law. When people talk about Ohm's law, they're usually referring to the first triangular formula. But the fourth property of electricity is the power in a circuit. And the power is really a measure of the work done by the electricity in the circuit. So when we're looking at a circuit that provides lighting, the work done is the production of light by the bulb in the circuit or by the LED or whatever. So when we talk about that amount of work done, we're talking about the number of watts of work that is done. And there's a whole bunch of different ways to measure work done. There's joules and all kinds of stuff like that. But we're just going to basically stick with watts for our purposes here. And every electrical device that you come across will have its power rating indicated on it in watts. So if you buy a microwave oven, you'll probably see that somewhere on it it's listed as a 1200 or 1500 watt microwave. Light bulbs that you buy, they indicate the amount of work done by the number of watts of light. So you'll buy 60 watt or 100 watt incandescent light bulbs. In the case of a more energy efficient bulb like a compact fluorescent or even an LED, the wattage will be quite a bit lower. So it'll be a 4 or 5 watt light bulb. And the thing that makes those lights so efficient is that they produce the same amount of light while the electricity does, much less work than an incandescent bulb, which is why everybody switched over. Anyway, that's kind of beside the point. But the power calculation triangle works in exactly the same way that the Ohm's law calculation triangle is. So if you have two of these unknowns, two of these are known, and you can find the third one simply by manipulating the formulas in the triangle. So we're going to use one that we're going to do an example that has an unknown amperage. So now that's kind of interesting. Try and get rid of that guy. So our amps are unknown. So our intensity is not known, but we do know the energy. So in this case, it is a 14.5 volt circuit. And we know that there are two light bulbs in the circuit of 65 watts each. So we know that the power equals 130 watts. So we have an unknown, and the unknown is the current. So according to this formula, I equals P over E. So I is unknown, P is 130, and E is 14.5. And if we do the calculation, we'll see that the intensity in the circuit is 8.97, and that's amperes. All right, that's pretty easy. So that triangle's easy to use. Why are they related? Well, because basically if you have two of the unknowns, you have two known qualities of electricity, or you know two of these things. You can find the other two by employing both of the triangles. So in this case, we know what the power is, what the intensity is, what the energy is, and we know what the current is, but what we don't know is the resistance. So how could we find the resistance? We could take our newfound intensity value, which we know here, and we can now plug it in because we know the energy and now we know the current, and we can find the fourth unknown, which is resistance. So that would be simple. R equals E over I, which equals E is 130, and our I is 8.97. So we do a little quick calculation. 130 divided by 8.97, and we get our final number. It's a 14.49 ohms of resistance. 14.49 ohms of resistance. So if you've got any two of these properties, you can find out the other two by using the triangular formulas in tandem. So that's it. This should be enough for you to do your homework exercise, and I hope you get it. If you don't, ask me questions.